The modernization of the global electrical grid is colliding with a severe chemical bottleneck. Regulatory mandates are forcing the rapid phase-out of sulfur hexafluoride. This gas is the industry standard for high-voltage insulation, but possesses 23,500 times the warming potential of carbon dioxide. As shown on the chart, this regulatory shift has caused procurement lead times to balloon. By late 2024, average lead times for sulfur hexafluoride-free switchgear reached 60 months. This represents a 233% increase in procurement latency since 2018. Even traditional equipment now faces a 42-month wait. The transition is not a simple chemical substitution. It requires entirely new physical architectures. This bottleneck is systemic across the global manufacturing oligopoly. The three dominant grid infrastructure producers face unprecedented backlogs. Combined orders for Siemens Energy, Hitachi Energy, and GE Vernova reached $75.5 billion in 2024. This represents a 178% increase from 2019 levels. Hitachi Energy experienced the largest absolute growth, with its backlog rising to $31.2 billion. This surge is driven by high-voltage direct current projects and alternative switchgear mandates. GE Vernova's grid segment backlog grew at a 24% compound annual rate. The physical capacity to build transmission equipment cannot keep pace with capital allocation. The bottleneck is rooted in the physical limits of factory retooling. Transitioning a single production line for regional transmission switchgear requires $16 million and 18 months of physical reconstruction. At ultra-high voltages, these requirements escalate to $35 million and 30 months. Furthermore, the transition introduces new chemical dependencies. While lower voltage classes use clean air, transmission-grade systems require proprietary fluoronitrile gas mixtures. This concentrates supply chain risk in specialized chemical processing nodes. This transition resembles the chlorofluorocarbon phase-out under the Montreal Protocol of 1987. Once again, regulatory mandates are forcing a capital-intensive redesign of heavy industrial infrastructure.